In this short video, we'll be looking at how to work out ionic formula using the periodic table. Remember, metals lose their outer electrons to gain a full outer shell underneath, whereas non-metals gain electrons to form a full outer shell. So group 1 metals lose 1 electron, becoming a +1 ion. Group 2 lose 2 electrons, becoming a +2 ion, and so on. Group 5 gain 3 electrons to produce a full outer shell of 8. Group 6 gain 2 electrons, forming a full outer shell, so they have a charge of -2, and group 7 only need to gain 1 electron to find a full outer shell, becoming a -1 ion. Now, the only transition metals you need to know about are the following. Both copper and zinc both form a +2 ion. Iron is an actual transition metal because it forms more than one type of ion. So it can form iron 2 or iron 3, and you'll be told in the formula which one it is. So let's go and practice each of these. So the first thing is we need potassium chloride. So the first thing I'd write is potassium, and that's a +1 ion. So I'm just going to put a plus around there, and chlorine is potassium chloride. Potassium reacting with chlorine, that's in group 7, so that is a -1 ion. You'll notice those charges are balanced. The potassium loses 1 electron, the chlorine gains 1 electron. That is the formula. So let's go on to magnesium bromide, which is magnesium reacting with bromine. So magnesium is in group 2, so it forms a 2+ ion, whereas bromine is in group 7, so it has a - ion. Now notice this time those charges are not balanced. Magnesium leads to lose 2 electrons, bromine will only gain 1, so you need 2 bromines to take those 2 electrons. Now if you look, you've got 2 minuses, 2 pluses, that is balanced. So sodium nitride is sodium and nitrogen. Sodium is in group 1, so that's a plus charge, and nitrogen is in group 5, so it's got a -3 charge. So this time nitrogen needs to gain 3 electrons, sodium will only give 1 each, so we need 3 sodium atoms to provide the 3 electrons, and you can see 3 pluses balances the 3 minuses. So copper chloride, we've got copper is the transition metal and its charge is always 2+. Chlorine is in group 7, so it's got a -1 charge, and so we need 2 chlorines to take the 2 electrons, and you can see those charges balance, and we just continue like that. Now aluminium oxide is a slightly trickier one. If we look, aluminium is in group 3, so it forms a 3+ ion. Oxygen needs 2 electrons, forming a -2 or 2- ion. Now what you've got to this time is find a common denominator of the 2, which is 6. So 3 2s are 6 and 3 2s are 6. Now what that tells you is if we've got 2 aluminium atoms, they need to lose 6 electrons in all, and we've got 3 oxygen atoms to take those 6 electrons. Another one with the 3-2 combination is beryllium phosphide. So we've got beryllium is in group 2, so it forms a 2+ ion or +2 ion, and phosphorus is in group 5, so it forms a -3 ion, and you can put the minuses and pluses either way around. So again, the common denominator is 6, so we'll need 3 beryllium atoms to provide 6 electrons for 2 phosphorus ions. So again, those work. And finally, iron 3 oxide, you know which charge it is because you're told it's 3. So we've got iron 3, it's 3+, oxygen is 2-, and therefore again that's another one with a common denominator of 6. So we've got 6 electrons given away to be accepted by 3 oxygen atoms for 6. So now you've got used to those, the next thing is we need to also be able to use what's called polyatomic ions. So these are molecules that possess an overall charge. you can treat them just like individual ions. And these are the ones you need to know. This is a hydroxide ion with a minus charge. This is ammonium ion with a +1 charge. This is a sulphate ion with a -2 charge, a nitrate ion with a -1 charge, and a carbonate ion with a -2 charge. Now, you need to know those for your exam for applied science. So you've just got to learn them before you go in, but be able to apply them. So let me show you this. So we've got calcium carbonate. So first I'm going to do like last time, I'm going to put calcium, that's in group 2, so that's 2+ charge. I'm then going to write carbonate, which you need to learn the formula for, and you need to know that that is a 2- charge. And you can see that those charges balance, so we've got to do nothing else to that formula. Now let's try magnesium hydroxide. Magnesium is in group 2, so 2+. Hydroxide, as you can see, is OH, and it's just a minus. Now, of course, magnesium needs to lose 2 electrons. The hydroxide ion altogether will only have taken 1 electron, so we need to multiply this by 2. But you have to be careful. You're not multiplying the hydrogen by 2. You're multiplying all of the hydroxide by 2. You need to put it in brackets. So let's look at zinc nitrate. Zinc is always a +2, and nitrate is NO3, and it's just a minus ion. So again, we need 2 nitrates for the zinc, so we need to multiply that by 2, and we multiply the whole thing. So let's quickly look at iron 3 carbonate. Well, iron 3 tells you it's a 3+ ion. Carbonate is a 2- ion. So again, we've got our denominator of 6, so we need 2 ions to make 6 electrons to give away, and we need to have that in brackets, and we need 3 carbonates in all to take those 6 electrons. What about ammonium chloride? Well, ammonia is NH4, and that's a + ion, and chlorine is a - ion, so that's balanced. So that is ammonium chloride. Iron 2 nitrate. Again, this time we've got a 2+ ion. We've got nitrate is NO3, and I put a minus there. It's a - ion. So again, iron needs to lose 2 electrons, and nitrate will only take 1 of them. So we need 2 nitrate ions to remove both of the electrons from iron. And finally, copper sulphate. Copper again is always a +2 ion, and you just have to learn that. Sulphate, SO4, and that is a 2- ion. Again, those charges are balanced. That is the formula for copper sulphate. So finally, sometimes in applied science, they will give you a word equation and ask you to produce a symbol equation and balance it. So we're using the exact same thing, but doing one stage at a time. So we've got sodium carbonate. So we've got Na. I'm going to put charges above just to help me, and you as well. Carbonate is CO3, but it's a 2-. So therefore, we need 2 sodiums. So that's sodium carbonate plus hydrochloric acid is hydrogen chloride, and hydrogen always produces a +1 ion. So it behaves like a metal in this situation. So we've got hydrogen, chloride is hydrochloric acid, chlorine is minus. That is the formula, nothing else we need to do. Goes to sodium chloride. So sodium we know is plus, chlorine we know is minus. That again is balanced for that. Plus water, you just have to know water is H2O, and you have to know carbon dioxide is CO2. Finally, we need to balance that equation. So I'm first spotting that I've got 2 sodiums on this side, I've only got 1 on that side, so I need to multiply the whole of that by 2. I can't put a 2 there, I will change the formula of sodium chloride. So now I've not only got 2 sodiums here, I've got 2 chlorine atoms here. I've only got 1 on this side, so I'm going to times the whole of that by 2. I've now got 2 hydrogens on this side, which is fine because I've got 2 hydrogens on there. The only 2 things I need to check now is I've got 1 carbon on this side and 1 carbon on this side, and I've got 3 oxygens altogether on this side, and I've got 3 on that side. So that is balanced. So I hope that video has helped you to work out how to work out ionic formula using the periodic table, which you'll get in your exam.